Myoelectric sensors are a rather new innovation in the fields of science and engineering. So the goal of this project was to demystify the ideas centered around myoelectric sensors and to make them more easily accessible to the common public. To do this, our goal was to take the Myo sensor and integrate it into an RC car.
The items that we decided to use for our project were a Raspberry Pi Pico board that cost $4, a USB cable that cost $2, a MyoWare muscle sensor that cost $38, a biomedical sensor pads that cost $17, a breadboard that cost $17, an RC car and batteries that cost $10, a Seed Studio accelerometer that cost $3.13, a QIA chip wireless remote control switch that cost $7.19, a Kunkai L298N motor drive that cost $7, and 160 male and female connectors that cost $12. All this costs a grand total of $117.32.
The major thing that we wanted to take care of in order to make sure that the RF transmitter and receiver worked was we needed to replace the wires that were connected originally to the motors, as you can see here. You can see the new solders here in this picture. This is our first test of the myoelectric sensor. You can just barely make out the LED coming on and off on the Pico Maker board. We tested the circuit for the RF transmitter and receiver with an LED setup, as you can see here. The button press from the Pico is picked up by the RF transmitter, sent over to the receiver, and the corresponding LED comes on. As you can see, when we press GP20, the blue and white light come on, whereas when we press any other button, it's just the white light. This is our first successful test of the Myo car. This is the basic setup of the completed project. The Myo sensor is attached to the arm sends out the signal to the Pico relays it to the transmitter relays it to the receiver, and the car moves. This is the basic circuit schematic in case anybody wants to try to replicate our design.
Through the process of creating this EMG sensor RC car prototype, I learned and got to practice more on many mechatronic topics that consisted of building circuits on breadboards, interfacing I/O pins to sensors, and analog to digital conversion. This project was fun because it gave me super hands-on experience that I haven't done before. Also, I found it very interesting how EMG sensors are and how they work in the medical field. I personally was never exposed to them and how they work and how powerful they can be in today's world for medical purposes and for teaching the younger generation.
What I learned from our project was how powerful EMG sensors can be if used correctly. With technology advancing, I could see it becoming very useful and groundbreaking, specifically in the medical industry. While we are still researching and discovering the use of cybernetic prosthetics, I hope to see it help combat disabilities that may interfere with their quality of everyday life and overall allow them to gain some basic mobility back.
I had always known about robotic prosthetics from mostly video games and my other engineering courses, so it was very entertaining for me to be able to experience the Myo electric sensor and what it can actually do, especially the programming and the circuitry for it. All in all, it was a very enjoyable experience to work on this project, and I look forward to doing many more projects with myosensors in the future.